Hello everyone, in the last class we learned about the function, performance indicators, and classification of turbines. Today, we will learn about the turbine rotor disc shaft connection and disc-disc connection. The turbine rotor is the collective term for the rotating parts of a turbine, including the rotor blades, turbine disc, turbine shaft, and connecting parts. The turbine blades convert the thermal, kinetic, and potential energy of the combustion gas into mechanical energy. The turbine disc carries the centrifugal loads and torque generated by the high-speed rotation of the blades. The turbine shaft is responsible for power output, transmitting torque, and axial force. As a high-speed rotating component, the turbine rotor is subject to significant gas loads, centrifugal loads, and thermal loads. Therefore, the connections between the turbine, rotor disc, and shaft between discs, and between the rotor blades and the impeller disc must be given due attention. Let us first learn about the connection between the turbine rotor disc and shaft. In most cases, the disc shaft connection is the only way for the turbine to transfer heat to the bearing. Its structure directly affects the improvement of the bearing working conditions, so the design of the disc shaft connection should have the following special requirements. First, the turbine disc is massive, so the connection must possess sufficient strength and rigidity to reliably transmit various loads. Second, the disc and shaft must be reliably thermally centered during assembly and operation, and the connection structure must be robust to avoid disrupting the rotor's balance. Third, the connection must have high thermal resistance to minimize heat transfer from the disc to the shaft and bearings. Turbine disc shaft connections are generally categorized as either non-detachable or detachable. Below, we'll first analyze the non-detachable disc shaft connection. Common non-detachable disc shaft connection options include radial pinning, welding, and forging into a single piece. Radial pin connections offer advantages such as simple processing, reliable operation, and easy machining. They also ensure thermal centering of the rotor. However, their disadvantages are that the rotor has many components after connection, and manufacturing deviations can affect rotor centering and balance. The connection requires wider and thicker structures, which increases rotor weight. Furthermore, radial pin connections have strict design specifications and are not suitable for all applications. As shown in the figure, the WP7 engine disc shaft connection is a typical non-detachable pin connection. They utilize a tight fit on the cylindrical surface of a specially designed mounting edge. Holes are then drilled and reamed through the assembled mounting edge, and radial pins are pressed in. To prevent the pins from flying out during operation, the holes are indented or blocked with other components. Welding is the simplest connection method for turbine discs and shafts. Its advantages include the lack of fasteners and light weight. It offers a simple structure, good rotor bending rigidity, and minimal imbalance. As shown in the figure, the high-pressure turbine of the RB199 engine utilizes this structure. However, due to the need to ensure concentricity between the disc and shaft, and to account for the effects of different materials, the welding process is very demanding. The third type of non-detachable disc connection is forged into a single piece. This has the advantages of no connectors and light weight, but it also has the disadvantages of low material utilization, difficult processing, and inconvenient maintenance. Therefore, it is only used in small gas turbines. As shown in the figure, the high-pressure turbine of the JT9D engine adopts this structure. Other engines that use this structure include the high-pressure turbines of the P4000 and CF6 engines. Next, let us take a look at the detachable disc shaft connection. Commonly used detachable disc shaft connection solutions include short bolt connection and sleeve gear connection. Bolted connections are a common method for turbine disc shaft connections. They effectively ensure rotor bending rigidity and the robustness of flange bolted connections. Typical flange bolted connections utilize a specially designed flange edge to locally strengthen center and position the connection, followed by tightening with short bolts. As shown in the figure, this is a schematic diagram of the turbine structure of the CFM56 turbofan engine. We can see that flange edges are processed at the front and rear ends of the high-pressure turbine disc, which are respectively connected to the sealing disc and the rear shaft neck, and then axially tightened with short bolts. A sleeve gear connection is also a common method of connecting a turbine disc to a shaft. It typically uses sleeve gears to transmit torque, a cylindrical surface for centering, and a large nut for compression. The figure shows the two-stage turbine rotor of a J85 turbojet engine. The rear shaft of the compressor extends near the turbine disc. The turbine stub shaft is integral with the first-stage turbine disc. The two shafts are centered by two cylindrical surfaces with sleeve gears transmitting torque and a large nut for compression. Next, let these learn about the connection between the turbine disc and the disc. In a multi-stage turbine, the design of the disc-to-disc connection should meet the following requirements. First, the disc-to-disc connection should have sufficient link strength and rigidity. Second, it should ensure thermal centering between structural parts in a high-temperature environment. Third, it should ensure the stability of the connection section between the load-bearing structures. Fourth, the thermal stress of the connection should be small. And fifth, it should be easy to assemble and disassemble. Based on the above design requirements, turbine disc-to-disc connections are usually divided into two types: non-detachable disc-to-disc connections and detachable disc-to-disc connections. Let's first analyze the non-detachable disc-to-disc connection. The non-detachable disc-to-disc connection is often used for turbine rotors with fewer rotor stages. Because the operating temperature of the turbine is high, the uniformity of the circumferential rigidity of the casing is more stringent, and longitudinal, non-split casings are usually used. Common non-detachable disc-to-disc connection solutions include radial pin connections. As shown in the figure, the connection of the two-stage disc of the turbojet 6 engine adopts radial pin connection, which is composed of two-stage wheel discs, blades, bearing rings, and turbine shafts. The bearing ring and the disc are centered by a cylindrical surface with tightness on the special mounting edge, relying on the radial deformation difference at the mating surface during operation, or radial pins, to ensure good thermal centering. Connected by tight radial pins and transmitting torsion and axial forces. Next, let these analyze the detachable disc-to-disc connection. The detachable disc-to-disc connection usually has short bolt connection and long bolt connection. As shown in the figure, this is the four-stage low-pressure turbine of the CFM56 engine. Short bolts are used to connect the discs. The drum is designed to be sunken to reduce the tangential velocity of the connecting flange edge. This can reduce the stress level around the flange and the bolt holes. The sealing grate teeth are separate parts and are clamped between the drums. This is beneficial for reducing stress and facilitating maintenance. Long bolt connection is also a common connection form for turbine disc connection. As shown in the figure, the three-stage turbine disc of the W6 engine is connected by long bolts. The turbine rotor of the W6 engine is a detachable cantilever rotor. There are connecting bosses on the front and rear ends of each stage disc. According to the force, transmission size, and rigidity requirements, it is connected to the shaft with 5 long bolts and 5 shorter bolts. The centering and torque transmission between the disc and the shaft and between the discs are achieved by pressing the surfaces A and B with a taper of 1/48 on the long and short bolts, with the corresponding tapered bolt holes on the disc. Students, in this class, we have learned about the connection between the turbine rotor disc and the shaft, and the connection between discs. After class, please review the occasions for using each connection method, as well as the advantages and disadvantages of each connection method. Thank you.